No, 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 I already recorded it. Yeah. Highlighters ready. Okay. I want you to remember sum of any four-sided polygon is always going to be 360 degrees. That's for triangles, we know it's 180. So for rectangles or squares or anything four-sided, it's 360. So let's make sure we understand that, right? It's going to be 360 on the inside, the interior angles, right? If you have a rectangle, right, it's still 360. If you have something that looks like a diamond, okay, it's 360. If you have something that looks like a trapezoid, it still has four sides. The interior angles still add up to 360. So that's a very important concept to remember. Do you know? Remember what supplementary angles are? Supplementary add up to 180. It's still going to be required of you to know when to apply that. So you will see how that comes into play. Now that we've done this, so this is the quadrilateral section. I'm going to leave. I'm not going to talk about parallel lines or anything else. I always found that it takes a long time to review all those concepts. You learned that in grade 10. I'm going to do it a different way. Yeah. Oh, okay. We will, once we talk, you know how I said we're going to do triangles and then four-sided and then polygons? Once we get to polygons, I'll show you the formula. There's a formula that allows you to find the sum for any number of sides. What's that? Oh, no. It's going to be, it's essentially, can I put it this way? Why do you ask so many questions? That's a good thing. Yeah. So basically, the main idea is this. Just make sure you pay attention, right? Otherwise, I move on. If you look at a rectangle, really, if you slice that in half, right? How many, these angles here will add up to, and these will add up to 180, 180, 360. You can prove it, but not in this course. I'm not gonna. That's a good YouTube search right there. Okay, backside. So you see 190 is completely blank. By the end of today, that's going to be completely filled in. Yeah. So what I would recommend you have is if you have two different colors, like pens, two different color pens, like blue and red or green and red, or something that sticks out because I'm going to add color to it. Okay, here we go. I will call this at the very top. I will write down properties of quadrilaterals. And that's just a fancy name for four-sided polygon. If you think about it, triangles is a fancy name for three-sided polygons. You don't consider it fancy because we use it all the time, right? And so that is the title of this page, right? I will write it one more time. Sum of the interior angles, that can always be used, okay? You can always use that property for these ones. So I will always talk about two shapes that are somewhat the same, but they have unique differences. So for example, the first one is going to be the parallelogram. Sometimes I just call it this, parallelogram. Okay. This is what a parallelogram looks like. It's a slanted rectangle. Okay, it's a slanted rectangle. And one of the properties is that this side, look at there, you put an arrowhead this going that way and an arrowhead going this way, indicates that these sides are parallel. What does parallel mean? Same way, they will never meet. They'll never cross, right? Parallel lines have so much in common, to God they'll never meet. That's a good joke there. So these two are parallel as well. So they go exactly the same way as, and they will never meet. So that's why I use blue there. Another property of the parallelogram is that this side measures the same as the other side. So they measure the same in length, right? And this side measures the same as that side. I think that would make sense. Okay. Or it's going to get a little full here, but this angle right here, I don't want to write them all out. You're going to be, if we write all these properties, it takes forever. Is the same as this angle right here. Okay. Shh, pay attention. This angle right here is the same as that angle right there. And you would have to agree that, right, the opposite, like these two angles would be the same. These two look like they would be the same, right? So there you have it. Let me zoom in a little bit if I can. Okay. Parallelogram. Then you have the rectangle. You're writing this down, right? Rectangle, we all know what that looks like. The first property about a rectangle is you should know that all angles are 90. Okay, all 90. Right? So that makes it very unique from the one on top, right? The parallelogram. We still have the fact that these two are the same and these two measure the same. So there's no news there. We know that they have two pairs of parallel sides. Don't put one arrowhead on all of them, because then you're saying all four are parallel, which is clearly not the case, right? So let's write what they have in common. Common properties. So they share things, but then there are things that make them set apart. Okay. So I will start with the common properties, right? Four sides. Yeah, they're all four sides. So we're going to leave that one, but it's a good one. Two pairs of congruent angles. The symbol for congruent is this. It's an equal sign with a little wave on top. Okay, so it just means they are the same. You have two pairs of, I'm just going to say this, parallel sides. Both of them have that. And they also have two pairs of congruent sides. So two pairs of congruent angles, two pairs of congruent sides, four pairs of congruent angles. And this is where they unique properties. Okay, so I'm going to go unique properties. So we're going to go parallelogram, and we're going to go rectangle here. So parallelogram, let's draw another parallelogram. It's important to get this right. You have two diagonals. You have the, let me get this right. This is the long diagonal, right? From end to end, that would be the long one. And here to here would be the short diagonal, okay? And on the rectangle side, both diagonals are exactly the same. Oops. I will do this, long diagonal, and the short diagonal. Right? And here, both diagonals are congruent. And here's where you have to make sure after you write this down, you get this part right. Diagonals bisect. Bisect means it's a fancy word for cut each other in half. So the red one, if you consider this point of intersection, this stretch and this stretch would be exactly the same from that point where they cross. So make sure those markings are there. And the long one is also cut in half, but because it's longer, those stretches will be obviously different than for the red one. Okay. When you look at the rectangle, since both diagonals are the same, what can we say about these stretches? They're all going to be the same. Looks like a flag of some country, right? Almost. So there we go. Let's add this though. So this is unique. I want to add here all angles equal to 90 degrees. That's another very unique to the rectangle. Okay, go ahead. I'm going to add this here. Diagonals bisect, cut in half. But the parallelogram has a long and a short diagonal, whereas the rectangle has both are exactly the same. But they still bisect nonetheless. They cut each other in half. Yeah. Didn't you just go? Okay. All right. So let's cut this now. So I'm going to make a line here. Okay. Next we have there's the rhombus. Rhombus is a slanted square. Pay attention, guys. Rhombus is a slanted square. So make it look like a square that is just slightly offset, right? So we know that all four of these sides are exactly the same. So that makes it a rhombus, right? You can't say, if you need to be specific, does it kind of look like a rectangle, like a parallelogram? It does, it's slanted, right? But what makes us unique is that you have all four sides being the same. Okay. That's right. Okay. So this angle is the same as this. This angle is still the same as this angle. And we have that, how many pairs of parallel? Yeah, we still have that going here. Okay. And then we're going to go and add the square here, square. We still have all four sides being the same. We have all angles being 90. Okay. So the difference between a square and a rhombus, the first one would be the angles are all 90. And then what am I missing here? The parallel sides, right? There. And then we'll put down the properties. Common properties. All sides are congruent. Let's use that symbol again. Two pairs of congruent angles. Diagonals bisect. You should know what that means by now. This is very specific. Diagonals meet at 90 degrees. That's very, very important. I'm going to highlight that. That's how you know that it's not a parallelogram nor a rectangle, because diagonals meet at a 90. Okay. And so we're going to, on the side here, what do I want to add here? I want to talk about the diagonals again, because you need to be able to, more so than actually stating the property, just be able to make a diagram where you show me that. Okay. So you have your, right, the long and the short here, they're different. In this case, for a square, you just have that. But notice what's important here is that you have your 90. Okay, both of these meet at a 90 here. And I will highlight that fact. Okay, it's very important to have. Can we just add the fact that it's still going to cut them in half, right? That's still the same. And here, all of them measure the same. So if I asked you, hey, what's the difference between the rhombus and the parallelogram? Let me just go up to parallelogram. The biggest difference is that or one of the differences is that the diagonals do not meet at a 90 here, but they do for a rhombus or a square. Okay. And last, the trapezoid. That's it. I want to do a few examples yet. So cut this right there. And then you talk about trapezoid. There's the, I'm going to put the right trapezoid on the left. Right? And the isosceles trapezoid on the right. Okay, so the right trapezoid looks like this, and the key here is the right. It has a 90-degree angle. We're not done yet, okay, so don't fall asleep here. So that's right there is important to make note of, and it has one pair of parallel sides. Whereas the isosceles trapezoid looks like this. It almost looks like an isosceles triangle that has been truncated, like cut, the top has been cut off, right? And so we still know that these are parallel, but not the same in length. That should be pretty obvious. But which two sides will be the same in length here? It will be these two here. Okay. I will also tell you this. This angle right here is the same as this one, whereas the base angle here and the base angle there would also be congruent. And some properties to go with this. One pair of right angles, one pair of parallel sides, whereas this one has one pair of parallel sides, one pair of congruent sides, two pairs of congruent angles, diagonals are congruent. Say what? Diagonals are congruent. So what's the alternative of what I just gave you? Reading 2 to 3 pages worth of properties and you trying to synthesize that, right, to kind of narrow it down. And you tell me, right, I think this is a little easier to digest than to read 3 to 5 pages worth of properties. These aren't all of them, but these are the ones that are going to help you the most. If you want to read more, the book has a bit more on that. You're good? Okay. So now that we have this, what's going to happen here, Mr. Dixon? Where is this going to go? I will ask you this. Draw an isosceles trapezoid and label at least 2 properties. At least 2. So your job is to actually draw this with the markings, not all of them, but at least 2, right? So let's go and practice that right now. So 191 is completely open there. Oh, it's because I missed the shape, sorry. We're going to talk about the kite yet. That's the last one. Kite. This is on 191. Think of this when you're thinking of a kite. 2 isosceles triangles stacked. But you cannot tell me that on a test. Like, hey, give me a property of a kite. Oh, it's 2 isosceles triangles stacked. I want you to think of it, but not actually use it as part of your explanation as to why a shape fits the kite category. So here's, I will make 2, okay, 2 kites. So the idea is, can I make this clear? The idea is that one of the triangles has to be longer than the other, right? They have to have different heights. Because if it's not, if this one is the exact same as that one, we're actually talking rhombus, okay? A rhombus is kind of like a kite, but it has all 4 sides the same. So here we have that this angle is the same as this angle, that this side measures the same as that side, that these two are the same as well. So do you notice that, right? These are two different triangles stacked, but not equilateral, okay? What's the other thing that I want to mention? Let's draw it right underneath. So here we have two diagonals. We have a short and a long, right? Does it look like they're bisecting each other? Yeah. Yeah, so we don't in this course, like we don't have a diamond shape. So that's not a shape. Don't use that for naming purposes. A lot of students do that on the provincial exam. I don't know, you freeze, you panic, looks like a diamond. So they put diamonds. Like we never talked about a diamond, right? It's a kite. Okay, this is not cut in half, but this one is. The shorter one is cut in half. And this is another one that the diagonals meet at a 90. Okay, so here it is in written form, but still a lot shorter than you would normally, right? Two pairs of congruent sides, right? Shorter diagonal is bisected. So notice that a parallelogram, a rectangle, they were all bisected, like they bisected each other. In this case, only the shorter one is bisected, not the longer one. One pair of congruent angles and the last one is diagonals are, here's the fancy word of the day. What's perpendicular? If you're perpendicular, that's parallel. They intersect. So when streets are perpendicular, they meet at a 90. Hey, don't worry about it if you didn't know, because you don't use it on a rate like that word is not being used very often, is it? But there it is. But streets usually meet they're perpendicular to each other. All right, so here we go. Let's cut this. And we're going to end with this. Okay. This is very important. I think students struggle with this. Right? Like with my short 12-year career, right? I've seen it all. Not yet. There's always a surprise here and there. So we're going to sketch each shape labeling two properties. Just marking it is fine, but sometimes I will ask you, hey, how is a rhombus different than a square? How is it different? A square has all angles 90, whereas a rhombus doesn't, right? So you need to know the differences here and there. So let's say I ask you to sketch me a parallelogram. We're going to do three possible answers that a student could do this. So let's do this. So let's just make sure you have a parallelogram, three versions of it. That should be a slam dunk, right? Making it look like a parallelogram shouldn't be the hardest part. So version one could be, hey, I know that this side and this side is parallel, so are these two. So you're talking about sides being parallel. That's property number one. Property number two, what could we talk about? What else do we know? Sides are the same, not all. So that's where you're going to be very careful, right? You're going to say those two. I know what you were trying to say, but that's why I'm doing this, right? So this one is done. Two properties, we're done with that one. So I'm going to start my second one. I'm only want to talk about angles, okay? You're going to do this. Now you're telling me that those angles are the same. We talked about angles. Perfect. And you can now throw in side lengths if you want. Right? So we did angles, we did side lengths. The what? The crossy thingies? The crossy thingies called diagonals? Yeah. So, right, this one and this one, you don't have to use different colors, but that's not quite good enough unless you write it, that one is shorter than the other. But do this. Just tell me that these two, right, the diagonals cut here, and they also cut here. That's a lot of work, but now all you did is you talked about the diagonals. You have to do one more thing, one more property. How about we do this? Parallel lines. Could you do side lengths? But it gets complicated because you have already one markings, right? Two markings. So now you do 3, 3, 4, 4. So you gotta be careful, right? You gotta be careful. So let's do another one. Kite. Let's say I ask you to draw a kite. 3 versions of it. Don't pack yet. We're good. We're good. I'm actually, it's a little off, but yeah, anyways. It kind of looks like a kite. We'll let it go today. So this is the same. And these two are the same. So are these two. You would be getting 2 marks right there. Don't do more than what I ask you, because a lot of students do that. And then you get it wrong because the markings aren't quite jiving, right? My next here is I'm going to talk about the diagonals. I'm going to say that they meet at a 90, and this one is cut in half. You're good to go. Those are 2 separate properties. I want to do one more. Can we say anything is parallel? That doesn't work. But we can say, hey, these two are the same. These two are the same. And now I'm going to throw in the diagonals. Meeting at a 90. Done. Right? So I think that's it for today. Yeah, we'll leave it here. So tomorrow's AC, I'm gonna do this. I'm gonna ask you to draw and label the properties for any one of them. Okay. So be ready for that. Maybe beef up your study sheet.